Hello again. This is Math 2231 coming to you from the College of DuPage, and the title of this lecture is Key to Midterm Spring 23. As always, please be attentive while watching this video. Some of these concepts may in fact appear on the comprehensive final later in the course. So problem number one, if you were to evaluate this limit, you can just plug in x equal to 0 into this term with a cosine, but you have to do something here because otherwise you will get 0 over 0. So what you will do then is you will plug in x equals 0 into this term, getting cosine of pi over 6, and we will take the minus 4 over 5 and pull it through the limit. But then we have to multiply top and bottom by 3 over 2. So 3 over 2, but here it's going to be 3x over 2x because we know this limit is going to be 1 and this limit is going to be 1. But if we multiply by 3 over 2, we have to divide by 3 over 2, which is the same thing as multiplying by 2 over 3. So we get minus 4 over 5, 2 over 3, and when we plug 1, 1, and this is square root of 3 over 2, and so we get this number here. It is minus 4 square root of 3 over 15, and that is equivalent to this expression that we have here as well. Number two, again, you were to evaluate the limit or declare that it doesn't exist. The key to this problem was to realize that this limit as x goes to 0 of ln of pi minus ln of x plus pi all over pi x is just 1 over pi times the negative derivative of the natural logarithm function. And so the derivative of the ln of x is 1 over x. We make it minus 1 over x times plugging in pi, it is minus 1 over pi times 1 over pi, it's minus 1 over pi squared. Number 3 was also evaluating the limit or declaring it doesn't exist. The key to this problem, I suppose, was realizing that 0 is between minus 1/2 and 1/2, and the absolute value of 2x minus 1, if we are less than 1/2, is this expression, so we substitute that in, and the absolute value of 2x plus 1 when we're greater than minus 1/2 is this expression, so it is this minus this expression in the numerator divided by x. When you do this calculation, you will get minus 4, and this shows that the graph will also yield minus 4, even though the function is not defined at x equals 0. Problem number 4, we were to find all values of a so that this is continuous on R. Well, the numerator is going to be, this is going to be continuous, the top function, and the bottom function is also continuous because they're polynomials, except possibly at a. So we have to find a such that this will be continuous. So the limit from the right has to be the limit from the left. So this is the limit from the right, and this is the limit from the left, so we plug those values in. And we get a squared is equal to a plus 1, and that means a squared minus a minus 1 is equal to 0, and that means that these are the two values for a. A can be 1 plus or minus the square root of 5 over 2. And that actually is the golden ratio, and here's some additional information that you may want to familiarize yourself with. This is a very famous number. Number 5, we were to take the derivative and evaluate it at pi. Now this is x goes to 2x, 2x goes to tangent 2x, tangent 2x goes to sine x. So this is several instances of the chain rule. We're to take the derivative and plug in x equal pi. So the derivative is going to be 2 cosine of tangent of 2x times the derivative of this, which is secant squared 2x, and the 2 came from doing the chain rule on this as the last step. So when we plug in pi, we know that the tangent of 2 pi is 0. That's the cosine of 0. 2 times the cosine of 0 and this is the reciprocal of the cosine, so it's going to be 1. So the answer to this problem should have been 2. This was number 6. You were taking the derivative and evaluating it 1. The easiest way to do this, I think, is to distribute. You could have used the product rule, but to distribute x to the 2/3 across here, and this is x to the 1/4. I think that's how I solved it. Let's see. Yeah, so when we distribute, we find that another representation of h was h of x is equal to x to the 5/3 plus x to the 11/12. Again, using properties of exponents. Then I have to take the derivative. It's going to be 5/3x to the 2/3 plus this is going to be 11/12. That is x to the minus 1/12, which puts it in the denominator. When we plug in 1 for x, we're just adding these two fractions, and we get 31/12. Number 7, again, another derivative problem. We're letting j of x equal, this is a quotient, it's e to the x cosine x over 2 minus x. Now it's important to realize that even though it's a quotient, the numerator has a product in it, and we're to evaluate j prime at 0. So it's going to be denominator times derivative of the numerator. Again, it was a product, so we get this, minus numerator times derivative of the denominator. The derivative of the denominator was minus 1, and then this is 2 minus x whole squared. If I put in 0 for x, I get 4 in the denominator, and 2 times 1 plus 1 is, so it's 3/4. Number 8, we were to find the derivative, evaluate this derivative at pi. And notice, my dear students, that this time we have 3 factors. It's the first function, the second function, and the third function, but we did study Leibniz rule for this, so we know how to evaluate this product efficiently. I'm pretty sure that's how I did it. Let's see how I did. Okay, so it is the first 2 times the derivative of the last one, and that's going to be a cosine x, because it's going to be cosine squared x here. And then it is 2x again times the derivative now of the middle one, and the derivative is going to be a negative sign. So this is negative sine of x times sine of x is negative sine squared of x. And then here the derivative of 2x is just 2. So we plug in pi everywhere, and we find that this is 2 pi as our answer. Number 9. We're assuming we have f being continuous and differentiable on this closed interval. Those are the hypotheses for the mean value theorem. And we know that f of minus 7 is minus 3. And moreover, I tell you that f prime of x is less than or equal to 2 for all x inside that interval. So what's the largest possible value for f of 0? This is similar to an unquiz that we did in class. It will involve the mean value theorem. So from the mean value theorem, we know that there is a f prime of c such that f of 0 minus f of minus 7 is f prime of c times the whole of 0 minus a minus 7. And when we simplify that, we get this expression. Now, we also, though, know that f prime of c is less than or equal to 2, so that means we can say that f of 0 is equal to this, but that's less than or equal to, that is 7 times 2 minus 3, which is 11. So the answer is that f of 0 is less than or equal to 11. Number 10 may have been algebraically the more difficult problem that we have here. To determine the equation of the lines that are tangent to that ellipse, 1 over 16x squared plus 1 over 4y squared minus equal 1, and pass through the point 4, 6. Well, the answers are going to be x equal 4, that is one of the lines, and the second line is y minus 6 is equal to 2/3 times x minus 4, 2/3 times the whole of x minus 4. But let's talk about how we solve this problem. And here's just a graph where I show that, yes, those are definitely solutions to the problem. So what we do is we use implicit differentiation on the equation of the ellipse, and we find out that dy dx is equal to minus x over 4y. And that's for y not equal to 0. And that means that when y doesn't equal to 0, then we have y minus the y coordinate is equal to the slope, and this is the slope times x minus the x coordinate. Now the x0, y0 here is the 0.46, and we're talking about a point on the ellipse, which is xy. So you end up with this being one equation, and again, for this dy dx, you substitute minus x over 4y. And the other equation that you have is xy is on the ellipse, so that means x squared plus 4y squared is equal to 16. I multiplied all the way through here by 16 to make this easier. So you will plug in this value for the derivative. That gives you one equation, and you will solve it simultaneously with this equation. The details of the algebra are here. You're solving a quadratic equation for x. Again, algebra is your friend, and that's what you can get. You get two solutions for this. When you plug them back into the equations, and here's the details, what you will find is that x is equal to minus 16 over 5, y being 6 over 5, and x being 4, y is equal to 0. And you can use the slope that we found out before in these points to write the equation of the line as I showed you earlier. Number 11, you were supposed to find the equation of the linear approximation to this function y equals f of x equal cosine 2x at the point x equal pi over 3, and I did ask you here to put your answer in the form y equals mx plus b. So you take the derivative to find the slope. That's going to be minus 2 sine 2x. When you plug in pi over 3, you will get, let's see, minus the square root of 3 is your slope. And so that is your slope, and then you have to figure out what is the xy value. X was pi over 3, and when you plug in to the function itself, you find that that's minus 1/2. So it's y minus the y coordinate is equal to the slope times x minus the x coordinate, and you write that in the form that I asked you to do. And so the solution is going to be y is equal to negative square root of 3 times x, and this is the intercept, which is the square root of 3 over 3 pi minus 1/2. And here I'm showing you that, yes, graphically that certainly works the way we expect it to. Number 12, you were to determine the absolute extrema of g of w is equal to e to the w cubed minus 2w squared minus 7w on the closed interval from minus 1/2 to 5 over 2. I think we also did this problem in class as an unquiz. We do find that the absolute maximum was e to the 23 over 8 at w equal negative 1/2, and the absolute minimum was e to the minus 392 over 27 at w equals 7 over 3. Let's talk about how you solve this, though. What you will do is you'll take the derivative, so g prime using the chain rule is 3w squared minus 4w minus 7, and here's e to the w cubed minus 2w squared minus 7w. And we're going to factor this way and set it equal to 0. Now we realize that the exponential is never 0, so I can divide both sides by that, and I'm going to look at, well, when are these factors equal to 0? So I get critical numbers that would be either negative 1 or 7 over 3. Only 7 over 3 is in the interval that we're interested in, so w equals 7 over 3 is our critical number. We do have to test the endpoints of minus 1/2 and minus 5/2 to determine what happens at those. So we substitute in getting these numbers, and we do identify the absolute maximum happens as I specified at let's see, that is 23 over 8 at w equal minus 1/2, and the minimum happens at the critical number in between, which was 7 over 3, and it was e to the minus 392 over 27. Number 13 was a related rates problem. You want to find the rate at which the height of the water was changing at the instant in time when the radius at the top of the water was 10. And Jesse Hayes Carver did suggest I provide some geometry grace notes, and I did that in your problem 16. And so, you know, that could have helped you along the way. This is going to involve similar triangles, and again, this is similar to some problems that we did in class. A key from the similar triangles to get so we don't have two variables, r and h, but we have a single variable, is we recognize that similar triangles gives us that r over h is equal to 26 over 8, and that means that r is equal to 13 over 4h. So we're going to plug that into the volume equation, and here's the volume equation. Volume is equal to 1/3 pi r squared h. So when we plug that in to the volume equation, this expression here, what we will get is that the volume is equal to 169 over 48 pi, and then that is h cubed. And then we take the derivative of this with respect to t. So dv dt is equal to, the constant just sits there, this is going to be pi h squared times h prime. But you see, we know that r was 10, and so if we know that r is 10, we know that h is 40 over 13. So we can plug in 40 over 13 up here. The v prime was 12. We knew that, so we 12. The only thing we need to know is what is h prime. And so we can solve for that, and h prime is 3 over 25 pi. Number 14 was a rectilinear motion problem. A particle moves along the axis according to this equation, and we're saying t is greater than or equal to 0, and is measured in seconds. Find the time when the particle's velocity and acceleration are equal. Well, the velocity is going to be the first derivative, and the acceleration is going to be the second derivative. So I set these two equal, and I solve for when are these two equal, and that means I get everything on one side and set it equal to 0, and I'm doing the algebra here. You have to use the quadratic formula again, so you get t is equal to 1 plus the square root of 37 over 4. Again, I insisted that t was bigger than or equal to 0. Number 15, an open rectangular box with a square base is to be made from 48 square feet of material. What dimensions will maximize the volume? Well, the answer is x is 4 and y is 2. The square base is 4 by 4, and the depth is 2. I didn't ask you, but the volume is 32 cubic feet. Let's look at the solution. Okay, so the total surface area of the box was 48, and that's the area of the base. You don't have any lid though, so it's 4 times the area of one side. So this is going to be x squared, that's the square base, and this is 4xy. So now you see 48 was equal to that, so I can solve this for y, and I get y is equal to 48 minus x squared, and this is all over 4x. And if I divide, I have that this is 48 over 4x. That's really going to be 12 over x minus, and this is going to be x over 4. Okay, so we remember that then, and we can say we want to maximize the volume. So it's going to be length times width times height. That's going to be x times y, x squared times y. So the volume is x squared times y, but now we substitute what we found that y was in terms of x into the problem, and we multiply it, and we find out the volume is equal to 12x minus, and this is going to be x cubed over 4. So we take the derivative of that, and we will set the derivative of that equal to 0, and we see that x, when we factor that, we'll see that x is plus or minus 4, but the length can't be negative, so it's x equal 4, and I plug back in here to find out what y was, and y had to be 2. Because I will have 48 minus 16 is 32 over 4 times 4, which is 16, and so y is 2. So that is where I get those answers. In closing, now more than ever, time is precious. Each day must count. Do the math, it will make you strong. And now more than ever, take care of yourself, because self-care is important. And now more than ever, take care of each other, because we're all in this together. Look forward to seeing you in class. God bless you all.